Hello, Year 6. Hope you're well and you've had a fantastic weekend. We've came to the end of the topic now on separating technique. So over the next two sessions, we are going to do some revision in preparation for your assessment on Thursday. Okay, so going back to the very start of the topic, we first looked at making a solution. So what do we need to make a solution? Well, there's two things that we need to make a solution. The first thing that we need is a solute. In this case, the solute that we're going to use is salt. Okay, we need to place that into a solvent. In this case, it is going to be water. Okay, collectively, the solute and the solvent will make up a solution. Okay. Okay, so here's a graph and it tells us all about solubility of salt within water. On the x-axis along the bottom there, we have got the temperature of the water in degrees Celsius, and up the side we've got solubility, so how much salt will dissolve within the water. And as we can see, as we increase the temperature of the water, the amount of salt that dissolves within the water increases. So as you increase the temperature of the solvent, the amount of solute that you can dissolve in that solvent will increase. Okay, so you may be asking yourself the question, why does more solute dissolve in solvent as we increase the temperature? So on the PowerPoint, I've included three different temperatures of water. We've got chilled water, room temperature, and heated water. So the chilled water may be around 3 degrees, the room temperature may be 21, and the heated water may be at 90. Okay, now what is the difference between those three different types of water that's in front of us? And to answer that, we need to be talking about particles and how they are arranged. Now, with the chilled water at 3 degrees, we can see that the particles in the water are much closer together. And because they're much closer together, there's not as much room for the salt to dissolve in between those water particles. If we move to the room temperature water, we can see that there's more thermal energy within the water, so there's more space for the salt particles to dissolve amongst those water particles. And again, if we move over to the heated water, we can see that there's an awful lot more space in between the water particles, so more salt can dissolve. Okay, so the first separating technique we'll look at is filtration. Why would we use filtration? Well, we would use filtration to separate something that was insoluble. A good example to use is sandy water. Now, as we know, sand does not dissolve within the water, so we would say that it is insoluble. So we're going to take the contents of our sandy water and we're going to place it inside of a beaker. Give it a good stir and we will pour the contents of the beaker into a funnel. And inside of that funnel, there will be some filter paper. So what does the filter paper do inside of the funnel? So if you've got something that is soluble, such as salt within the water, that will travel through the filter paper. So why does water and something that is soluble travel through? Well, if we were to look very close up at the filter paper, we would notice that there is tiny little holes within the filter paper, and the particles that make up the salty water are small enough to travel through, so they will collect in the conical flask. However, the sand that we wanted to originally get rid of will remain behind inside the filter paper, and that will form what we call the residue. Okay, the particles of the sand are too big to travel through the filter paper, so they will remain behind. Inside the conical flask, we will have salty water, and the salty water is now known as the filtrate. Okay, so now that we've separated our sand from the mixture, we need to separate the salt from the water. Now, if you only want to retrieve the salt, the best process to use is evaporation. So what do we need in terms of equipment for evaporation? Well, first thing is we need a thermometer, so we have an understanding of the temperature of our solution. We need a beaker. We need our solution, our salt water solution that we have separated during filtration. We would need a gauze to place our beaker on top of, a tripod, obviously a heat-proof mat, and we would also need a heat source in the form of a Bunsen burner. Okay, so we've placed our salt water solution inside of the beaker. We're going to heat it to 100 degrees. Why 100 degrees? Because that is the boiling point of this solvent. Once it's reached 100 degrees, the water will evaporate into the surroundings, leaving behind the salt. Why, you may ask, the salt remains behind? Well, the boiling point of the salt is much, much higher than that of water, so the salt will remain behind inside the beaker. Okay, so next separating technique we're going to look at is chromatography. When would we use chromatography? We would use it to separate a mixture. Okay, going through the equipment that we require, first thing we need is filter paper. We need a solvent. Now, 90% of the time, the solvent that we need to use is water. However, if you are ever asked to use an alternative to water, the best solvent to use as an alternative would be ethanol. Okay, so step number one in chromatography is to get our filter paper and to draw a pencil line on there. Why do we use pencil to draw that line? Well, pencil is insoluble within the water, so it will not be absorbed up the filter paper like the other colours will be. Step number two is to place the mixture on the pencil line to which we are wanting to separate. Step number three will be to place that filter paper into the solvent, so just the bottom of the filter paper is touching the solvent. Okay, once we've got it set up like this diagram on the left hand side, we need to wait approximately 10 minutes for the water to be absorbed up the filter paper. So after those 10 minutes, we can clearly see that the yellow dye has travelled up the furthest. That tells us that yellow ink is the most soluble within the water. And at the bottom, we can see the purple dye has barely moved off the original starting point. So the purple is the least soluble ink within the mixture. And if any of the inks did not move off the original starting point, if we did have to try and separate that, we would use the alternative to water, which would be ethanol. Okay, so last separating technique we're going to look at is distillation. When would we use distillation? We would use it to separate a solution when we wanted to retrieve both the solute and the solvent. So unlike evaporation, in evaporation we heat the solution, the solvent is evaporated, only leaving behind the solute. In distillation, we should be able to retrieve both the solute and the solvent. Okay, so going through the equipment that we require for distillation, we need a tripod, a Bunsen burner, a gauze, a flask to place our initial solution inside of. We need a thermometer. the special piece of equipment, the Liebig condenser. And lastly, we need a conical flask. Okay, so we're going to place our solution, our salt water, into the flask, and we're going to heat that to 100 degrees Celsius. Why do we heat the solution to 100 degrees? Because the water's boiling point is 100 degrees. Therefore, it should turn into a gas at 100 degrees. What will be left behind in the flask will be the salt. Why is the salt left in the flask and not evaporate like the water? Well, the boiling point of the salt is much, much higher than that of water, hence why the salt remains behind in the flask. Okay, so the water has evaporated and it's moving up the flask and it moves into the Liebig condenser. So as it moves into the Liebig condenser, it's in a gaseous state. It's a gas. And what we want to happen inside the Liebig condenser is to turn that hot gas into a liquid so that we can collect it in the conical flask. Okay, how do we do that? Well, we've got water coming in and water coming out of the Liebig condenser. Okay, so the water coming in goes all the way around the Liebig condenser, creating a very cool environment. Now, as the gas is traveling through the Liebig condenser, the heat energy from that gas goes into the cold water, and consequently, the hot gas condenses back into a liquid and is able to be collected inside of the conical flask. And once it's collected inside of the conical flask, the liquid, the solvent, is now known as the distillate. Okay, now if we did not have that Liebig condenser with all of the cold water going around it, the gas, the water vapor, would not condense and we wouldn't be able to collect it in the conical flask, and instead it would remain as a gas and move out to the environment. Now, as well as separating a solution in distillation, we can separate a mixture of two solvents. So a good example of a mixture of two solvents would be ethanol and water. Now, the boiling point of water, we all know, is 100 degrees, and the boiling point of ethanol is 78. So they're both colorless liquids. They've been placed into the flask. What we would do is to heat the mixture up to 78 degrees. What would that do? The ethanol would evaporate at 78 degrees, go down the Liebig condenser, and form the distillate. The water would remain behind in the flask. Okay, so there's an awful lot of key vocabulary that we need to remember for this topic, which is why for the rest of this session and Tuesday's session, I want you to revise ahead of your assessment on Thursday. Now, how you revise is entirely up to yourself. You can make cue cards, a revision poster, encompassing all the different techniques and all that key vocabulary. You can make a pick collage. As well as that, if you Google Key Stage 3 bite-size separating techniques, there's about 6 pages of revision on there, which goes through the separating technique topic incredibly well. Now, the assessment will be on Thursday. You will receive a PDF with that on. Write the answers to those questions in your book, and there will be a video going through the answers for you to mark that assessment. Okay, so get some revision done today and tomorrow, and I will give you your assessment on Thursday with a video going through the answers. Okay.